All right, today we're going to talk about something super interesting, a technique that's making AI feel way faster. It's called speculative decoding, and it's basically all about teaching an AI to think ahead.
You know that feeling, right? You ask a chatbot something, and then you just wait, watching the words pop up, one by one. It's like watching someone type with just one finger. That little delay, that latency, that's exactly what we're tackling today.
So, to really get why AI can feel so sluggish sometimes, we've got to look at the root of the problem, this big bottleneck and how it actually generates text.
Okay, so at their core, these huge language models use something called an autoregressive process. I know it sounds super technical, but the idea is actually pretty simple. The model spits out one word, or even just part of a word, we call that a token, and then it looks at that token to figure out what the very next one should be. It's this one-by-one, step-by-step chain reaction.
And here's the crazy part. We have all this incredibly powerful hardware, right? These massive GPUs, but this one-by-one process means all that power is just sitting around, twiddling its thumbs, waiting for the next token to be generated. It's like having a Ferrari just to drive to your mailbox. That's the bottleneck. That's what's causing that frustrating lag.
So, how do we get around this? Well, with a really clever shortcut. It's this predict and verify idea, where we basically let the AI jump ahead of itself and then double-check its own work.
And this whole technique is called speculative decoding. So instead of going one by one, what it does is it pairs the big, powerful AI model with a smaller, much faster drafting partner. This little partner just rapidly spits out a few words, and then the big model comes in and checks them all in one go.
Honestly, the best way to picture this is with a great analogy. Imagine a brilliant chief scientist and a super efficient assistant. The assistant, that's our little fast draft model, just scribbles down a bunch of ideas, a whole sentence maybe. Then, the chief scientist, our big, super accurate model, just glances over the assistant's work and approves it all in one single batch. It's so much more efficient.
And the payoff here is huge. It just slashes that latency, making the whole thing feel way more responsive. It boosts the efficiency of the whole system. And maybe the best part? It doesn't sacrifice any accuracy. We're talking 100% preservation of the original model's quality, because our chief scientist always gets the final word. Now, this whole scientist and assistant team-up can be put together in a couple of different ways. So let's check out the two main approaches.
So you've got the classic method, the draft target approach. This is literally two separate models, the big target and a smaller, faster draft model. But then there's a more modern approach, like this thing called Eagle 3, which is way more integrated. It's like instead of hiring a separate assistant, you attach a little drafting head right onto the main model. It's like giving the scientist a built-in, lightning-fast thought pad.
So with that classic two-model setup, it's pretty straightforward. Step 1, the little draft model suggests a few tokens. Step 2, the big target model checks them all at once. And then Step 3, this process called rejection sampling decides which of those suggestions are good enough to keep.
And this is how that decision gets made. It's actually pretty brilliant. The system looks at the probability scores from both models. So for Brown and Fox, you can see the big target model is actually more confident than the little draft model. Green light, they get accepted. But then we get to Hopped. The target model's confidence drops way down. It says, nope, that's a bad guess, and it rejects it. And once it rejects one, it throws out everything that came after it. This is the secret sauce that guarantees you get the exact same quality as the original model. Okay, so then you have something like Eagle 3, which takes this whole idea to the next level. Remember, instead of a whole separate assistant, this is more like a built-in coprocessor. It's a little head that's attached deep inside the main model, and it gets to peek at the model's internal thoughts. This lets it make way smarter drafts from the get-go.
And this integrated style has some seriously cool perks. For one, you don't have to train and manage a whole separate model, which is just way more efficient. Plus, it can generate not just one path forward, but a whole tree of possible options. And it's smart, it's adaptive. If it's feeling confident, it'll draft a bunch of words. If it's not so sure, it'll just draft a few. It's really clever stuff.
Okay, so that's all the theory, but what does this actually mean in the real world? What's the payoff? Let's talk about the actual speed boost we're getting.
All right, let's picture a super simple scenario. We just need the AI to generate 3 words, 3 tokens. Using the old school one-by-one method, this is what happens.
So if each step takes about 200 milliseconds, you do the math, 3 steps means a total of 600 milliseconds. That's more than half a second of just waiting for 3 little words.
Okay, now let's do the exact same thing, but this time with our clever predict and verify shortcut.
The assistant drafts the tokens, the
The scientist verifies them all in one single shot. And the result? The whole thing is done in just 250 milliseconds. We're talking less than half the time. It's a huge difference.
And look at this bar chart. It just makes the difference so clear. This isn't some tiny marginal improvement. We're talking about a massive drop in latency. This is literally the difference between an AI that feels clunky and slow and one that feels snappy and immediate.
And really, that's what it all comes down to, right? The user experience. The folks at NVIDIA said it perfectly. This creates a much more fluid and natural conversation. You're no longer watching text drip onto the page. You're getting thoughts and answers in complete, natural chunks.
So, pulling back a bit, what does all this really mean for the future? For how we're all going to be interacting with AI?
Here's the bottom line. Speculative decoding isn't just some niche little trick. It's quickly becoming a fundamental, core strategy for anyone running these big AI models. As we all demand faster and faster responses from AI, techniques like this are absolutely crucial to making the whole thing work.
And that leaves us with a really fascinating question to think about. We've spent this whole time on the how this works, but what about the what? As that annoying lag in our chats with AI disappears, shrinking from seconds down to almost nothing, how is that going to change how we talk to them? What new things become possible when our AI assistants can actually keep up with the speed of our own thoughts?